I'm going to start today by looking over arithmetic sequences. Arithmetic sequences are similar to linear functions. So arithmetic sequence is a sequence of terms that has have a common difference. And what that means is that you're adding or subtracting the same number each time. And when we're looking at a function, that adding or subtracting same number each time in linear is called a constant rate of change. So when you're talking about sequences, it's called the common difference, but when you talk about linear, it's called the constant rate of change. And since I'm here, I'm going to go ahead and make sure that you understand the only differences between sequences and functions is that sequences start at n equals 1, whereas functions start at the y-intercept where x is equal to 0. All right, so that's the only difference. So, and then of course the words are called different things. So again, common difference is in sequence. In linear, we say constant rate of change. All right, so let's write the explicit formula. So if I come into the formula sheet right here, I'm looking for arithmetic sequence formula, recursive, explicit. So this is the equation that I'm writing. Let's go ahead and copy that down. So this is a sub n is equal to a sub 1 plus d parentheses n minus 1. And we're going to quickly recap what each of those things mean. All right, this is going to be your first term. D is going to be your common difference or your constant rate. All right, that way you know both, right? So D is your common difference, your constant rate. A sub 1 is going to be your first term, and n is just the number of terms. Like, do I want the first one? Do I want the second? Do I want the third? Do I want the fourth? Do I want the fifth? Do I want the sixth? So remember, n always starts at 1. All right, so let me make that connection between I told you it's similar to linear and arithmetic. Remember, m is what? My constant rate of change, right? And I just said that the common difference and the constant rate of change is called d. So what I'm going to do is I'm going to draw an arrow from m to d. So in sequences, your d is your m, your slope. All right, let's go ahead and write the recursive formula. So that was the explicit. The recursive one is this. The way I remember cursive, okay, if you write in cursive, all right, in order to write the next letter, you must have the one before because you connect everything, okay? So that's what recursive means. So a sub n equals a sub n minus 1 plus d. And the big thing that you need to realize is a sub n minus 1 means the term before. Okay, that's all you need to know. So what you're doing is you're taking the term before and you're applying the constant rate of change to it. So if the term before is 5 and the constant rate of change is plus 2, then you're doing 5 plus 2, like that. All right, so we'll go into detail when we look into an example. All right, so let's go ahead and look at an example really quickly. All right, so we've got, count the number of boxes. How many boxes do you see there? 3. How many boxes do you see here? 3, 4, 5. How many boxes do you see here? 1, 2, 3, 4, 5, 6, 7. All right, so we're going to put that in a table. So you're taking your pattern, you're going to put it in the table. So what term gives me number of boxes? 3, the first one. So remember, sequences starts at 1, functions start at 0. So this is not the 0, 1, this is the first one. So the first term is 3. Okay, the second one is 5. The third one is 7, so that must mean we skip a box. Each time, what are we doing to it? We're adding what? 2, which is the constant rate of change or the common difference. Okay, so we're adding 2 to it every single time. So this is going to be 4, this is going to be 5, and I'm going to ask you to find the 10th one. So the common difference is 2. And how do I know that? Remember, you take your second value and you subtract your first value. All right, once you find out, that is your constant rate of change or your common difference. All right, so let's write this in explicit form. So explicit form here is your formula right here. So we're going to write a sub n, the first one, is equal to a sub 1. What is the first term? Well, we know the first term is 3, right? The first term is 3 plus my common difference, which is what? 2. So this is 2, parentheses, and n minus 1. Okay, so now what we're going to do is we're going to go from explicit functions to function notation. I'm just going to show you the relationship of why they're the same. Okay, then I'm going to prove it to you. So I'm going to do it right here. So I'm going to do simplify this right here. So to simplify that, I'm going to distribute 2 times n, which is going to be 2n, 2 times -1, which is going to be -2, and out here we just have 3 plus, right? So when I combine like terms, 3 minus 2, that's going to give me 1. So this is going to be 1 plus 2n. And if I was to write this in function notation, I'm going to first show you that it's going to be the same thing as this, only difference is instead of n, we have x. So remember, the only difference between sequences and functions is that sequences starts at 1, but functions needs to start at 0. So knowing that my equation for a function is y equals mx plus b, where m is the common difference, where I already know the common difference is 2. So that's going to be y is equal to 2x, and all I need to find out is what b is. B is the 0 term. So I know the first term, the second term, the third term, and I can see that each time I'm adding 2, so to go backwards I need to just subtract 2. So each time I subtract 2, and then I'll find the 0 term. So 5 minus 2 is 3, 3 minus 2 is 1. So this is going to be 2x plus 1. Of course, what you could also do is just put it right into Desmos, click the flag, you know it's linear, make sure you zoom fit to make sure that it's perfect. Yes, it is. And there it is as well, y is equal to 2x plus 1. So my function notation is f of x is equal to 2x plus 1. So we can go from explicit into function notation. And yes, we can do it by hand, but what we can also do is do it with the Desmos calculator. So you can type your explicit formula into Desmos just like it is. You can also do the a sub n part by saying a, 1, 2, 3, or rather a, b, c. Then you see this a sub b, that's a sub n. And then right click or move to the right arrow equals, and you can see your straight line. I can make this a table, but it looks like it doesn't like me making this a table, so that just means I don't need n in there. So I'm just going to delete the n and put x instead, because you know it only likes x and y. Make that a table and then hit the flag, and now I've got my explicit, my function notation. So I can go from explicit by typing it in, just changing the n to x, making a table, clicking the flag, and now I've got my function, or I can do it by hand like I just showed you. So whatever your preference is, I'm okay with that. Okay, so that's function notation. Let's take a look at recursive. So looking at my recursive one right here, we're going to write a sub n is equal to the one before plus my common difference. So it's the one before, which is a n minus 1. My common difference is 2, so it's just plus 2. And what that means is we can find any term given the one before it. Okay, so now if you're finding my 10th term, you can either use explicit or function notation to find my 10th term. We can't use recursive because remember, to find recursive, you need the one before. So if I was looking for my 10th term, I'd need the 9th term and then add 2 to it, right? But I don't have the 9th term. So you got to use explicit or function notation. Please give me the 10th term. All right, you're also going to complete this problem underneath, but I'm going to go ahead and get you started. All right, Ben is picking flowers in the garden. He picks 51 flowers from the first bush. So here's the first bush, 51. All right, 41 from the third, 26 from the sixth, 6 from the 10th. So go ahead and answer 6 through 10. Let's practice.